So we want to know what interval has the greatest average rate of change. So let's just look at these intervals here. So from -7 to -5, we go down to the function here, and I look at that. I'm really measuring that slope there. And then -5 to -2, that would be this line segment here. Well, let's see if I can make that line segment. And then -2 to 1, I'll do that in green. -2 to 1, that would be that line segment there. And then 1 to 2, maybe I'll make that yellow. 1 to 2, that's here, so that's that line segment there. And so what I'm looking for is the average rate of change is the same thing as the slope of these line segments. So what it's asking for is it's saying which one has the greatest average rate of change. I'm looking for the greatest slope. Notice that all of these slopes are positive. And so the greatest slope will be the steepest of these positive slopes. And so, so the answer then is D. And so this has the greatest slope. You have to be a little bit careful when the slopes are negative, because the greatest negative number is the one that's closest to 0. But anyhow, these slopes are positive, so we don't have to worry too much about that. So the next one, the temperature at which water boils depends on the altitude. The first question is the data in the table linear? And so how do we check to see if data is linear? We will want to look for the same average rate of change. So let's look for the first set of data. So if we do 208 minus 210 over 2.2 minus 1.1, so that gives me -2 over 1.1. So that gives me whatever that is. If I do the next interval here, I can do 206 minus 208 over 3.3 minus 2.2, and again I'm going to get -2 over 1.1, and then this one here I'm going to do 204 minus 206. I can see it's going to give me the same thing. Again, -2 over 1.1. So since those average rates of change on those three intervals were all the same, it is linear. So this is a yes. And the reason is because it has the same average rate of change. So that's the reason. Use a formula to express the temperature T as a function of the altitude A. Okay, so I know that this number here is my slope. If I wanted to write that as a fraction, I can write that as, that's equivalent to -20 over 11. If I multiply top and bottom by 10. So I can go ahead and write out my temperature. So I know that T is equal to -20 over over 11, excuse me. A plus some initial value, and that would be the temperature when the altitude is 0. So that's the temperature, it's at sea level, that altitude, or that the water would boil. And so I need to find that value, so I don't have it. So for now I'm just going to call it B, and we'll figure it out in just a minute. And so I can plug in some of my known values for T and A. So in here for T, I could put, 210, and then for A, I could put, 208. So if I go ahead and plug that, oh, sorry, not 208, I would plug the altitude that goes with that, so that would be 1.1. So let's go ahead and plug in that pair of A and T values. So I can say 210 is equal to negative 20 over 11 times the a value, which is 1.1, and then plus my b value, which I don't know, and then I can solve that for b. Okay, so I can just do in my calculator 210 plus 20 over 11 times 1.1 is equal to my b value, so let's see what all that is. Uh, 212. And that's a degree Fahrenheit. So now I can write down my formula. It's T equals negative 20 over 11A plus 212. So that is the answer to part B. On C, give the slope of the function and explain its meaning in practical terms. Okay, so the slope of the function is negative 20 over 11. Let's do the units for that. When I computed that slope to begin with, I had the temperature on top. So this is degrees Fahrenheit per, and then on the bottom, it's 1,000 feet. Maybe it would be better if we wrote it out in decimal. So the slope is negative 1.818 degree Fahrenheit per 1,000 feet. So what is the meaning of that? That means for each increase in 1,000 feet, increase of 1,000 feet in altitude, the temperature at which water boils will go down by 1.818 degrees Fahrenheit. So that's telling me how much it goes down for each additional 1,000 feet of altitude. At what temperature does water boil in still water, which has an altitude of about 900 feet? And so what we can do is I want to convert that to 1,000 feet. So that would be 900 feet is equal to 0.9 thousand feet. So that's what I want to plug in. So the temperature is going to be equal to negative 20 over 11 times 0.9 plus 212. And if I compute that, I get 210.36 degrees Fahrenheit. So that's the answer there to D. On number 6, I want to find the equation of the line that passes through those points shown on the graph. So at x equals 2 and x equals 4, so I'm given some x values. I need to compute the y values that go with that. And so what I can do to find the y value that goes with the x value 2 is I can plug it into the equation there. And so if I plug in 2, I can see that I'll have negative 1/2 times 2 minus 2 squared. That's just going to be 0 plus 1. So the point here is 2, 1. And what about at x equals 4? So if I plug in x equals 4 in for x, I get negative 1/2 times 4 minus 2 squared. So 4 minus 2 is 2. When I square that, I get 4. I divide by 2, so I'm going to have negative 2 plus 1. And negative 2 plus 1 is negative 1. So that's 4, negative 1. I talked through that kind of fast. Let me show you what I mean here. So y is equal to negative 1/2 of 4 minus 2 squared plus 1. That's equal to negative 1/2. 4 minus 2 is 2. When I square that, I get 4 plus 1. That's negative 2 plus 1, which is negative 1. That's what I was talking through. So now I have 2 points on my graph there, and I can compute the slope, and then I can plug in one of the points. So my slope is going to be the change in y divided by the change in x. So I could do -1 minus 1 over 4 minus 2. And I'm going to get -2 on top and 2 on the bottom. So that is my slope. And then when I plug in y minus y1 equals m times x minus x1, that's point slope form. I can plug in the slope that I had here for my m. And then for the y2 and y1, I can just pick one of my points. So I'll just pick the point 2, 1. So the 2 is an x value. I'll plug that in for x1. And the 1 is a y value. I'll plug that in for y1. So y1 is 1 equals, my slope is -1. X minus x1 is 2. And so there is my equation of my line. So that's the answer to number 6. On number 7, let's erase some of this stuff over here so I can write. Okay, so number 7, it says find an equation to a line that passes through the point -7, 1 and is perpendicular to that line. Okay, so the first thing we want to do is we want to find the slope of this line. And then we will figure out what a perpendicular slope would be. And then we can write the equation of a line that has that slope. So first let's figure out what the slope of this line is. So I'm going to start by adding the 5x to the other side. And then I can divide through by -2. And when I do 6 divided by -2, that's going to be -3. Okay, and so I can see that my slope of my given line is -5/2. So what that means is the slope of my perpendicular line is going to be the reciprocal, the negative reciprocal of that. So it's going to be 2/5. So that's the slope I want to use. M equals 2/5. And then I'll just use this point. And I have x1, y1. Is equal to -7, 1. So I have my slope, I have my point, so I'm just going to plug it in. Y minus y1 equals m times x minus x1, and then I can plug it in. So y minus 1 equals 2/5, x minus -7, so it's going to be x plus 7. So that's the equation of my line. Number 8, for a salesman, the profit when 10 vacuum cleaners are sold is $462, and the profit when 25 vacuums are sold is that. We're going to assume it's linear. What is the average rate of change in the profit for each vacuum sold? So to find that average rate of change, I'm going to do change in profit over change in vacuums sold. Okay, so 1422 minus 462 over 25 minus 10. So if I compute that, I'm going to get 64. And the units for that are dollars on top per vacuum. All right, and then write a linear function for the profit P as a function of the number of vacuums in that are sold. And so again, I can say P minus P1 equals M times N minus N1. And I can just use one of my values there. So I can do P minus, and I'm just going to use this first value. When 10 vacuum cleaners are sold, the profit is 462. So I'm going to use the 462 for my profit, for my P1. and then my slope again is 64, and then n minus n1, so n minus, and recall that, if we had 462 as the profit, then the number of vacuums that went with that was 10. Okay. So what I want, it asks for a function p as a function of the number of vacuums. So I am going to solve for p in this case. 64 times n minus 10 plus 462. And if you want, you can simplify that, but we'll leave it